Good afternoon, everybody. So I'm here to tell you about InfiniLED, which is a spin-out from the Tyndall Institute in Cork, and it is commercializing a new type of LED technology, which we call the micro-LED, and it is basically a semiconductor, a 3-5 semiconductor technology. So just to introduce myself, first of all, I'm the CEO and one of the founders of InfiniLED. My own background is in startup and spin-outs, and particularly focused on identifying interesting and dormant technologies in universities and trying to put the structures and resources around them to create a startup. My colleague Bill Henry was the original driver behind the technology, worked on the technology from a commercial perspective prior to the concept of the spin-out. And in a way, we're very lucky because we are talking about a very specific technology here, and we do have some very good technical experts working with us. It is not a everyday type of technology. We have Nick Shepherd, who has, who has many years' experience in LEDs, Tony, who has many years in packaging, and we have access to the inventors who are based in Tyndall and will remain academics, but are very important to the technology involvement. Bit of background to the company, how long we've been around, etc. I suppose, unfortunately, this technology has been around a long time. The original innovation was back in the early 2000s, and it stalled for some time, but the recent EI initiatives to try and support this kind of activity really got it going the last 2 years. Bill became entrepreneur in residence, looking at the technology. The business partner scheme, which I was involved in and which brought me as an outsider in to look at the technology, was in 2010. And from that then we basically put together the company concept, the product that we were trying to pitch, defined what the customers were, and ultimately early this year we concluded that there was a business behind the technology, and we created the spin-out and signed the license agreement with UCC in April, I think it was. Okay, since then we've been up and running. We are self-sustaining with revenue. We have POs, and that is keeping the company going, but we are now in full fundraising mode. So what is the technology and what are the products? What are we doing? Everybody, I'm sure, is fairly familiar with the LED, a light-emitting diode. It is everywhere. The previous speaker spoke about LCD displays. Most of them use LEDs. Ambient lighting now uses LEDs. They're everywhere. Okay? A typical LED in its own right, you'll probably see, this is how people normally perceive them, but the fundamental chip is about 300 microns square up to 1 millimeter. What is different in our technology? What is the core difference in what we call our micro-LED compared to normal LED? And fundamentally, it is these microstructures. This is the LED here. The light is emitted in this direction. We have these novel and patented microstructures that we put on the back of the wafer or on the chip, which causes the light to be collimated. And fundamentally, a normal LED emits light in every direction. We collimate the light. So in a way, we kind of moved LED into the sphere of a laser to some extent because of the collimation. These structures are extremely small. I have here one. Okay, so normally in a normal LED, this size is about 10 microns diameter, a fraction of the diameter of a hair, but you can still see it. Okay, and that is because of the way the light is collimated. Okay, and that's the core behind the technology, and that's the novelty. Oops, wrong one. So, performance benefits, okay, we have a collimated light beam. The collimated light means we get the light out better, so we have 4x enhancement in the light extraction, which is basically more light per unit current, which equates to a longer battery life. That is the core competitive advantage of the technology. We can get, recently we've just really proven, and this was a big objective in our R&D, we have proven that we can get a similar amount of photons per unit area, and the cost, the incremental cost in adding this structure to a standard LED process is minimal. The value propositions, we're the most collimated LED light available. We have the lowest power consumption per unit of light. In other words, we're a green LED. And another important point, jumping to the last one there, is the light is collimated, so we can put a large number of these little microstructures together without they interfering with each other. Now, what does that mean in terms of products? This is the core technology up here that I just mentioned previously. A single LED. So we have broken the applications that we can go after into 3 categories. There are applications that benefit from these very, very small LEDs. A lot of portable diagnostic kits only need very small amounts of light. A lot of displays, like the sample I showed you, only need very small amounts of light. A lot of catheters that go inside the body, they only need light in a very, very concentrated area. So there's an awful lot of applications that benefit from our ability to concentrate the light into a very, very small spot. And these are the first applications that basically drove the creation of the company, and most of our revenue are coming from these. Over here we have what we would call LED arrays, where each pixel, where we put a large number of pixels together, and each one is individually addressable. And that basically opens up the door to what we call maskless lithography. And there's a whole range of applications that use this ability to have an LED or a light source where you can, at will, switch on and off different pixels. Over here then is where, instead of having individually addressable pixels, we add them all together. So we fill a full LED surface with a whole number of these little structures. The end result is a very large LED, just like a traditional LED, but we still have all the benefits of enhanced optical efficiency, reduced battery power, etc. And this opens up all the doors to all the ambient, high brightness, car lighting, traffic light, all the other LEDs, with the inherent benefit I just described. So we have broken the whole products into 3 categories, and working in this direction, this is where most of the activity is today. And here we're still at the proof of concept stage in terms of proving the benefits and characterizing the performance of our technology. In terms of the process and other advantages of the technology, this statement here is extremely interesting. The LED market, which I'll talk about in a second, is extremely large. We've got many large players, and it's cutthroat in terms of IP issues, and the big companies are suing each other, and they're counter-suing each other. So it's a very complicated space from an IP perspective. However, our core technology and our core patent sidesteps a lot of the disadvantages and opens up the door to offer some of the tier 2 or tier 3 players a new way of solving their problems using our technology. So talking about the opportunity a little bit more detail, back to the 3 categories here. And just picking some at random, I'm not going to talk about all of these in detail because I'll be here all day, but some of the applications that we're really seeing traction on and some of the ones we're focusing on. Portable diagnostic instrumentation, as I said earlier, the challenge here is, and many of these instruments use optical detection, or they need LED lighting as the core of the detection method. What we offer them is extended battery life, less optics because of collimated light, so we can reduce lenses, we can reduce filters because we can add the filter functionality directly to the device. A lot of advantages which end up with an instrument which is potentially smaller, lower cost, and very importantly, longer battery life. And we have 2 key customer engagements there. One is looking at developing a glucose monitoring device that is actually put onto the skin and is disposable, which would be a very large opportunity if that goes all the way to the design end. And there's another one here as well, which is about a €1 million opportunity per annum recurring if we go all the way. Another application is back to the indicators or energy-sensitive indicators. Lots of applications like a mouse, the battery keeps running out all the time, and most of the battery is used to drive the LED. If you have a lower power, a lower energy consuming LED, you extend the battery life. We have one big customer that is looking at LEDs to power displays within the binocular system, or binoculars, a pair of binoculars, and that customer has tested the devices, and we're now waiting for a PO to develop a very specific solution for them. And that's a $500,000 opportunity per annum recurring if we can go all the way to the design end. Displays, okay, backlighting, LCDs. LCDs today, most of them are illuminated using LEDs. LEDs are put into the side of a light guide, okay, which then is the backlight for the LCD display. Cameras, watches, TVs is all the same. What's our benefit there? Because our devices are so small and we can customize them, we can couple them to very thin light guides, get a lot more light into the light guide. Again, the end result is longer battery life or less energy consumption. And this is particularly useful in the industry at the moment because all the backlighting for LCD displays is going to very thin light guides, 300 or even 150 microns, and standard LEDs just can't get the light efficiently into very small and very thin light guides. Customer traction, okay, we have a number of customers, but one here is, this is actually a prototype that they've been working on, which is, again, battery illumination. They have actually reported a 20x reduction in the battery consumption to illuminate this watch here, which is even better than we expected. Another application out of the second category, which is the addressable arrays, PCB manufacturing. The present PCB manufacturing process uses a whole number of masks. So some PCBs might be 10 or even 12 layers high, and they're all put on top of each other to make a printed circuit board. Each one requires a mask design. Therefore, it is impossible to make a quantity of one of a printed circuit board, or it is also very difficult to, or it's very expensive to change the design of a printed circuit board. So there's a big trend, a big push towards a maskless lithography, which takes away the masks. There are laser systems out there today, but lasers are slow, complicated equipment, or the actual capital equipment is very complicated. We offer speed, we offer resolution, and we offer less complexity. Key customer here is actually our biggest customer at the moment. We're working on developing an optical head or an optical engine for a system that they are bringing to market in conjunction with Fuji. And actually, that customer is in tomorrow morning, and I should be hopping on the train very quickly and getting down to Cork, but this is more important. Okay. So another example, DNA synthesis. Again, is, today they use many masks to develop a DNA microchip. Our solution allows that to be done with no masks. Over here on the latter end, the high brightness applications, and like I said, this is we're still at an early stage here, but fundamentally we can offer ambient lighting with a 2x reduction in battery consumption or energy or electricity consumption because of all the collimation and extraction efficiencies that the technology offers. And again, we're beginning to see some interest in these areas as well. Another interesting one, last one to talk about, is microprojectors. Again, microprojectors use 3 different color LEDs or lasers, red, green and blue. Again, the major issue here in any microprojector which customers or which companies are putting into mobile phones and cameras, etc., is battery consumption. Anything that can improve or reduce the energy consumed is very, very interesting, and we're just beginning to show traction there as well. In addition to the core technology I just described, which is a LED or 3.5 gallium nitride processing technology, through our agreement and interaction with the Tyndall Institute in Cork, we also have access to world-class packaging, optical packaging capabilities, and we have access to their foundry where we can actually run our own custom designs at will and in short time frames. The overall offering to our customers is not just the LED technology I just described, it is the packaging and customization as well to give full solutions. And most of the customers I referenced in the previous few slides utilize all these aspects of our capabilities and allows us to really engage with customers and offer them full solutions to their problems. These are just examples, again, at random. Single devices, larger devices, clusters, okay? This is a design particularly for a light guide, an elongated solution. Okay, who are our target customers? Most of them are manufacturers. They make some kind of equipment. Their revenue is multi-millions per annum, and they spend a lot of money on LEDs. Always under pressure to get better performing, more efficient LEDs, smaller, less complicated optics, etc. Our target contact is normally a CTO or similar. Disadvantage is there's a long design in between engagement and getting a design in validated in somebody's equipment, but once you're in, there is normally recurring revenue. And this is reflected in our revenue projections, which we'll come to in a second. Market size for LEDs, it is a very large market. It's about 13 billion this year here, and it's growing extremely fast. Okay, so the market, target market that we could technically go after is about 13 billion. Obviously, that's not realistic. We've broken it into a number of segments. These are the miniature ones that we're actually targeting at the moment. Again, in their own right, there are multi-billion opportunities. Massive lithography is also very large. The lighting applications in their own right are multi-billion as well. But the serviceable market that's real to us is about 1 billion. And this is calculated based on the key opportunities we're targeting, bottom up based on the customers and the opportunities that we're working at the moment. So we believe there's a very good and real large opportunity here for us. What's our plan? Okay, I've spoken about products. It's a very product-specific presentation to date. Okay, but we have a dual go-to-market strategy. The product focus, like I said, focus on niche high-value applications which exploit the core performance advantages of the LED. Obviously, as well, there's a licensing potential. The core technology is novel, and the only way to go after the $13 billion market, we're never going to do that ourselves, is going to be via licensing to some of the big existing global LED suppliers. And our target is not the tier ones, but we're now beginning to target and engage with the tier 2 and tier 3 LED manufacturers, many of them in China and Taiwan. So we have a dual go-to-market strategy. Operations plan. Okay, luckily we have access to Tyndall. We can do all our fabrication, all our packaging, and all our testing in Tyndall in the short term. Long term, we would be planning and obviously outsourcing to the low-cost locations to do this kind of work. We're a fabless model. We're never going to do anything ourselves, even though in the short term it's a little bit vague because we do work very closely with Tyndall and they do all our wafer manufacture for us. Revenue and cash forecast. Cut to the chase here. Obviously, is very hard to predict. We're talking about a multi-billion-dollar market. We're conservative in our views of the world. So we're showing here a slow ramp up to about 15 million over the next 3 or 4 years. This year we're going to do about 200,000, and that has been sustaining the company to date. We're almost a lot of the way there already. And in terms of funding, we're looking to raise about 2 million. We're actively pursuing 2 million at the moment. I'm showing a split here. 2 million we believe will get us through the development phases in the next 1 or 2 years and allow us to ramp up those OEM opportunities and also really push the licensing opportunities that I've discussed. Okay, last slide. So what are we trying to do? Okay, we need to build sales. We need to focus on licensing. We need to build our organization faster and get more resources. We need to optimize our process. We've taken the process out of an academic environment. There's a lot of issues to be sorted. And we need to strengthen our leadership. We're looking to find somebody, a CEO from the industry, from the LED industry. We need to put a board of directors in place. What we're offering investors is a 15 million revenue in a few years' time, 75% gross margin, definitely 1 billion serviceable market or more, and 2 million in funding is what we're seeking.
Great.
Thank you very much.
Any questions?
What range of the visible spectrum do the LEDs operate?
It's like any LED. We can make them at any wavelength. Okay, our focus has been blue and green. We've also done some in the NIR. Okay, red is on the pipeline. Okay, so fundamentally, this technology can be applied to any wavelength.
And does the efficiency remain the same, more or less, throughout the spectrum?
The benefits relative to state of the art will be the same. Okay, obviously it depends on the material.
One more question, Lee?
I have one
Yeah.
and forgive my ignorance here, but I think you described the technology a lot, but could you clearly articulate the problem that you're solving with this technology?
Okay, the main problem, or let's say the benefit relative to the existing LED technology is mostly around the enhanced energy efficiency. Therefore, more light per unit current, therefore less electricity used, less battery used, longer battery lifetime.
So for the market, though, is that a high order bit?
Yes, yes.
So that's a big dollar savings.
That's a huge dollar saving in terms of, obviously, if you can reduce in two the energy used for all the ambient lighting, that's a big thing. For any portable devices, mobile phone, laptops, the display uses a big percentage of your overall battery power. You extend that by 2, it has a big impact on your battery life.
Should we short the stock of battery manufacturers?
If we double the lifetime of a battery, somebody else will want to double it again. Okay, so keep your battery.
Why would computing or phones not be on your target?
Sorry?
Right? Computers or phones, right? I mean, that's a
Yeah.
huge deal. Apple
Yeah,
just came out
yes.
with a new phone, and the big sell was double the talk time.
Exactly, yeah.